Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. MainO2 is a mild, selective oxidizing agent that selectively oxidizes allylic and benzylic alcohols to their corresponding carbonyl compounds, aldehydes or ketones. It does not oxidize non-allylic or non-benzylic alcohols under normal conditions. Starting material analysis, the substrate is HO CH2, 3C is equal to CH2, CH2O. This molecule contains two hydroxyl groups. 1. A primary allylic alcohol, the CH2 or directly attached to the exocyclic methylene carbon, C, is equal to CH2, CH2O. This is an allylic position because the CH2O is on a carbon adjacent to the C is equal to CH2 double bond. 2. A primary non-allylic, homoallyl remote, alcohol, OCH2, 3 at the far end of the chain, which is not allylic. Selectivity of MainO2 selectively oxidize only the allylic alcohol, CH2O adjacent to C is equal to CH2, to give the corresponding aldehyde, CHO, while leaving the non-allylic primary alcohol, OCH2, 3 untouched. Product OCH2, 3C, is equal to CH2, CHO, i.e., 5-hydroxy-2-methylenepentanol, the allylic CH2O becomes CHO, and the remote O remains intact. This matches option C, which shows HO CH2CH2CH2C is equal to CH2, C is equal to O, H, an aldehyde formed by selective oxidation of the allylic alcohol with the remote homoallylic hydroxyl group preserved. Why other options fail? Option A. Oxidize the non-allylic terminal alcohol to an aldehyde while retaining the allylic alcohol, opposite selectivity, incorrect. Option B. Appears structurally similar to C, but the drawing in the original shows it differently, in context. Option B. May represent a different connectivity. Option D. Shows oxidation to a carboxylic acid, which MainO2 does not accomplish under standard conditions. Therefore, the correct answer is C. Therefore, the correct answer is option C.